Dear students, in the previous modules, we have learned how to store textual data and numeric data. And then there is another form of data, that is a form of images. So you take photograph of someone, so that photograph could be stored how into the computer. So whether it should be, we should follow the textual kind of approach or numeric kind of approach. So let's see how the images are going to be stored within the computer. So you might have heard about pixel. So that pixel is a short form of picture element. So PIX is picture and then EL is forming the element. So this is pixel. And this is appearance of each pixel is encoded to form a bitmap. Many display devices, printers work on pixel concept. So this means whatever the image you have, so you store that image in the form of small grids backend in the computer, and that each grid is a pixel. And if there is a color on this place, on this pixel, so then it is forming some image. So these pixels are very small that when they are combined together, they form a fine-grained image. So let's see how. So these pixels are converted to bitmap as I have shown on the previous slide. And in black and white images, each pixel is represented as 1 bit. So this means to display such kind of bitmap in the black and white screen, you just need 1 bit for each pixel. So whether it is black, so you can save 1 against it, and if it is white, then you can store 0 for it. So then the device is going to read that bitmap, so that is going to read it in the form of zeros and ones. But when we store black and white image, so we only store 0 and 1. But if the image is a gray shaded image, it has different shades, or there is a possibility that that image is a colored image. So then we follow some other techniques. So such kind of black and white images in the form of 0 and 1 are used in facsimile, which are the machines using fax. So handling shades, we normally do not use 1 bit, we use 8 bits. So in 8 bits, you can display the shades. And now I am expecting that you can now tell me that with 8 bits, how many shades of one color could be represented. So we have learned in the last module that with the 8 bits, we can represent 2 raised to power 8 combinations or unique bit patterns. So which becomes 32, 64, 128 and 256. So 256 types of shades could be represented with 8 bits. So we could have then variety of shades as the form of grayness. And to store colorful images, one of the technique we use is RGB, red, green, blue. So we want to form all of the colors of the world with the help of red, green and blue. So for example, we have 1 byte for red, 1 byte for green and 1 byte for blue. So which means we can store like 0, 0, 0, 1, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is 1 byte or 8 bits to represent red. Then we can represent 1, 2, 3, 4, 5, 6, 7, 8 for green and similarly for blue. So this combination of 24 bits will represent one color. So this means with RGB you can represent 2 raised to power 24 colors, which are more than 16 million colors. And then there is another way of brightness chrominance method. So one brightness component and two color components in brightness chrominance method. So brightness component is pixels luminance, sum of red, green and blue. So that is called luminance, or the sharpness in the image. And then there is another second thing, blue chrominance and red chrominance. So these are two colored chrominance, and difference between luminance and amount of blue or red is called blue chrominance, and difference between luminance and the red color is known as red chrominance. So these three components are used in the brightness chrominance method. And then there is a scaling of images. So you know, when we represent image in the bitmap, so if we want to extend this bitmap to a larger size, then it will be blurred. So we cannot digitally zoom this bitmap. So to digitally move this bitmap, we need large number of pixels to represent this image. So then there is another method to avoid such large scale image or small scale image to enlarge it, that is geometric structures. So they say that we should not store the bitmap or the pixels values. We should use the collection of lines and curves and using analytical geometry, and we see that how geometrical structures should be displayed rather pixel reproduction. So you say that what kind of curve would be here and to what kind of length it would be there, and what kind of analytical geometry we should use. So such lines of curves and lines we use in the geometric structures. So we actually are not storing the bitmap or image, we are storing that how much lines and curves should we form to display this image as a true image. And such types have been built by Microsoft and Apple, like TrueType, and PostScript by Adobe, and those are also used in computer aided design as well. So if we summarize today's module, we have learned that how to represent images in the form of pixel, bitmap, and then we have learned brightness chrominance method, and then we have seen that irrespective of saving the image, we should save that how the image should be formed. So that would be the metadata, that how the lines, how much line thickness and how much curve should be used to form the same image as we want to display the image accurately.